everyone, we're going to find the Maclaurin series for f of x, also find the associated radius of convergence. We have f of x equals hyperbolic sine of x. So let's look at this, and we're using our definition of Maclaurin series here. We're going to write it in this form. So we're going to start and crank out a few derivatives. So at first, let's just use 0. So we have f of 0 equals hyperbolic sine of x. And you evaluate that at x equals 0, and that equals 0. Okay, so for 1, our first derivative, so that's, we're looking at this one, of 0, that equals hyperbolic cosine of x, and evaluate that at x equals 0, we get 1. Let's try 2. So it's just going to go back and forth, and that's going to be 0. And let's try 3. Crank out some of these derivatives. Hyperbolic cosine of x. Let's do one more. Let's try 4. So the fourth derivative is going to be hyperbolic sine of x. That's going to be 0. So it just alternates between 0 and 1. So basically we can say that our nth derivative at 0 equals 0 if n is even, and it's 1 if n is odd. So every time that it's 1, so we have 1 here, that's odd, that's a 1, that's odd, and it's 0 every time we have even. So that's that. And now let's go ahead and write it as a sum. I think we can squeeze that in here. So let's write it here. So we're going to have this as a sum from n equals 0 to infinity. Now your x, it's going to be to the power of 2n plus 1 divided by 2n plus 1 factorial. All right, so now we're going to use the ratio test, and I'm going to write this again. We have the sum of n equals 0 to infinity of x to the power of 2n plus 1 divided by 2n plus 1 factorial. Now this is going to be like my a sub n. So let's go ahead and use the ratio test. We have the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So this is going to equal the limit as n approaches infinity, absolute value. Now for these n's, we're substituting n plus 1. So that's going to give you x to the power of 2n plus 3 divided by 2n plus 3 factorial. We're dividing by a sub n, so the same as multiplying by the reciprocal of this. So that's going to be 2n plus 1 factorial divided by x to the power of 2n plus 1. Now let's see what this equals. For the x part, let's see. When you divide this out, this is x to the power of 2n plus 3 minus 2n minus 1. So that's just going to give me x squared. And it doesn't, so I'll just pull it out, times the limit as n approaches infinity. And now let's look at these two. This part right here, 2n plus 3 factorial can be written as 2n plus 3 times 2n plus 2, and you keep going down 1, 2n plus 1. You can keep going, but we're going to stop at 2n plus 1 factorial, so these two cancel out. So we're left with 1 divided by 2n plus 3 times 2n plus 2. And as you take this limit, this is going to equal 0. And that is less than 1 for all x. So our radius of convergence is infinity. Thank you. Have a nice day. Bye-bye.